One of the things that we try to get across to our students from a content knowledge is the law of conservation. There are actually several laws of conservation. Law of conservation of mass or matter is typically the most common one that we discuss. I discovered that my students have a law of conservation of their own that I was completely unaware even existed, and they call it the law of conservation of volume. They are quite convinced that when you mix two liquids together, 50 milliliters of one or 50 milliliters of the other, it will add up to 100 milliliters no matter what. And I didn't actually recognize that until I was just doing a demonstration in my classroom and sort of realized the answer that they gave me was completely wrong. And so there are a couple of demonstrations you can use to clarify this and really get a visual picture for students to see what's going on. So one of the ones I do is that I'll take an ordinary beaker and I will ask my students, is this beaker full? To which most of them will say no. The occasional very bright student might say, yes, it's full of air. But most of this at this level, if they can't see it, it's not actually there. So they will assume that there's nothing inside of that beaker. So I will start to fill the beaker. And I'll just take some ping pong balls or golf balls and start to fill up the beaker. Maybe I can get one more in here. No, that's not really in there, so I'm going to leave it out. So I'll then ask them, is the beaker full? To which maybe half of them, and I have students vote, so you just say, if you think it's full, give me a thumbs up. If you think it's not full, give me a thumbs down. You can get a very quick visual picture. It's really safe because half the class will be up, half will be down. Actually, in a lot of cases, more than half the class at this point will say thumbs up, but it depends on the year. And then I say, okay, well, if it's full, then what happens if I put more into it? And instead of using ping pong balls, I'll use smaller spheres and start to use marbles. And so they now start to realize that, all right, there's a little bit of it, there's some space in between those ping pong balls. They're not exactly filling the beaker completely. You can get a little bit more inside. And so they start to recognize, okay, there's more to the story than it just being full. And so you can ask them at this point, is the beaker actually full? And they'll look at it and they'll say, well, maybe it is, maybe it's not. Sometimes I'll have to pour some of it out to get... Sometimes you have to do finagling to get the marbles down in there. And they'll say, okay, well, maybe now the beaker is actually full. And I'll actually do the same thing. Ask my students, thumbs up, thumbs down. Beaker full, beaker empty. Or not completely full, I guess I should say. And at this point, most of the thumbs are down, because they can actually see that there's more spaces in between, but there might be a few students that think that the beaker is now full. So then we go to the next size particle. And you can just get an ordinary shot, BBs from any sort of gaming store or anything like that. And then I ask them at this point, is the beaker full? And we can start to fill in a lot of those gaps in between the molecules by using some of the BBs. Now you can use copper shot. Anything that's small and regularly cylindrical or regularly spherical will work fine. So after we get to this point, my students can start to see that there's more spaces in between there that haven't been filled. You can go all the way to the very top here. But then I'll start to pull out even something smaller. What happens if instead of BBs, we start to use sand? So now there's even more space in between particles and in between the molecules. So we can now very finely start to fill in all of the gaps in between those BBs, in between those marbles, in between the ping pong balls. We now have very fine particles that can actually fit in the spaces that I've left before. Even if it doesn't look like anything else can fill, if we think about smaller particles, and there's very, very often always a smaller particle that you can find, you can very easily start to fill in those gaps between the spaces. And at this point, again, I'll poll my students and ask, is the beaker full? Give me a thumbs up if it's full. Give me a thumbs down if you think something else can still fit in there. And at this point, sort of squeezed out one of my ping pong balls. But at this point, almost all of them are going to say, yeah, it's full. You can't get, sand is really finely divided. You might get a couple of kids that say something else can still fit. But at this point, they'll say, yeah, that's completely full. And so at that point, they're like, yeah, you can't get, they can't even see gaps anymore. And so they assume that's completely full. And then I'll pull out this. What happens if we add water to this? So if you start to pour water over top of the sand, they can see that the water will even start to go down into the sand and seep in. Sometimes you might even get a little bit of air bubbles that are starting to form on the inside. But you can actually watch the water starting to percolate down through the sand grains. So even in between those very fine sand grains, you still have more space that can be filled in. And you can fill this all the way to the top. I usually stop at this point because this can become a bit of a pain to clean up.